Welcome back to the Deep Dive. So if you're with us today, it probably means you've moved past the foundational skills.
You're off the basics.
Exactly. You've mastered running a line, you can plumb a corner, and you're comfortable laying brick in that standard, efficient running bond.
And that's the functional apprentice level. It's solid work. It's what gets, everyday walls built quickly and reliably.
But function is just the beginning, isn't it?
It really is. I think every apprentice has to realize that true mastery in masonry, it demands a pretty fundamental transition.
A shift in mindset.
A total shift from just building a wall to truly creating a piece of enduring architecture. Today, we're taking those foundational skills and we're elevating them.
We're hitting into the historically rich, visually complex, and let's be honest, the structurally demanding world of pattern bonds.
Yeah, we are.
We're really diving deep into what separates the artisan from the laborer. I mean, when you walk through an older Canadian city,
Oh, absolutely.
Whether it's the historic financial district in Montreal or a government building in Ottawa or some old university campus facade, you're not just looking at a stack of clay units. You're looking at applied math, at engineering history, and just incredible craftsmanship, all laid out so meticulously.
And our mission today is to give you the blueprint for mastering that next phase of your career.
Right.
And if we could distill all the knowledge about pattern bonds into just one single truth, it would be this.
Okay.
When you get into ornamental work, success is 90% planning and only 10% laying.
That is the absolute non-negotiable truth. Yeah. Every professional mason knows it.
We've all seen it.
We've seen countless apprentices, they're confident in their running bond skills, and they try to rush a Flemish or a herringbone panel.
It just falls apart.
It does. And they realize the flaw wasn't in their trowel work. The flaw was that they failed to plan. They just didn't account for the geometry.
So let's start with the basics. We define a pattern bond as the arrangement of masonry units in a specific predetermined sequence.
Right, a pattern.
And this arrangement, it usually uses some form of overlap relative to the unit below it. And when you execute it correctly, especially, historically, this pattern enabled the wall to support imposed loads.
Which is why we call the classic ones structural bonds.
That's it.
And when we list out the whole family of pattern bonds, we're usually talking about 5 main categories.
Right.
You've got the running bond, which everyone knows, and then you get into the really distinctive, historically significant patterns, Flemish, English, American, or common, and then the structurally challenging stack bond.
We really need to put those first 3, Flemish, English, and common, into their proper historical context.
Okay.
For centuries, these were genuine, heavy-duty structural bonds. I'm talking 19th century homes, factories, civic buildings, places where the masonry walls themselves supported the full weight of the structure.
So the floors, the heavy timber roof, everything.
Everything.
And how did they actually achieve that? That load-bearing capability?
It was all about unit interlock. They used full headers, so units laid across the width of the wall that ran the entire depth, tying the 2 adjacent withes of brick together.
Into one solid monolithic element.
Exactly. That interlock, that genuine physical connection, that's the essence of their structural strength.
But I mean, the world of construction has changed so dramatically. We're now in the age of engineered systems and cavity walls.
Precisely. So today, those same classic patterns, Flemish, English, common, they're mostly used for their incredible decorative appeal.
Right, as a veneer.
Either as the outer withe in a cavity wall or in a veneered wall system. The real job of structural load transfer and tie-in, well, that's handled by internal steel components, engineered metal ties, and reinforcement inside the cavity.
So if you're looking at a beautiful English bond pattern on a modern high-rise in Toronto, and you see those short faces, the headers, on the facade.
It's almost certainly a snap header.
Oh.
It's just a brick cut in half, widthwise, purely for the visual effect of the historic bond. It creates the illusion of a tie, but it performs 0 structural load transfer between the withes.
So you have to know the difference between the historic function and the modern decorative use.
You have to, because that's what dictates your materials and your reinforcement needs.
Okay, so let's get into the details of the 2 strongest historical bonds, and let's start with the English bond. As a master craftsman, how do you help an apprentice, visualize this pattern?
English bond is it's a powerful composition. It's built on alternating strength. Visually, it's alternating entire courses of headers and stretchers.
Okay, so course 1 is all long faces, the stretchers,
Right.
running lengthwise.
Right.
And the course directly on top of it, course 2, is all short faces, the headers, running widthwise.
That's it.
I always tell my students, just stand back and kind of squint. It looks like a long, smooth ribbon of stretchers. And then right on top, a chunky, short block ribbon of headers.
And the geometric key to its structural integrity is that the headers are centered directly above the stretchers in the course right below them.
That precise centering is what distributes the vertical load so effectively across the whole wall area.
Exactly. The joints in the stretcher courses will align vertically, but that header course, it ties those stretcher courses together and, more importantly, historically, it ties the two wives of the wall together.
The moment of truth for any structural bond, though, it always comes at the corner.
Always.
This is where the geometric discipline is really tested. I mean, if you can't turn a corner successfully while keeping the bond, the whole wall fails visually and, in the old days, structurally.
And we've got two main ways of detailing the corner.
Yeah.
The English corner and the Dutch corner.
Okay.
Let's tackle the true English corner first, specifically for a single wythe wall, which you might see when you're detailing a fireplace or maybe a garden wall in this bond. To get that required offset right at the corner, you absolutely have to use a quarter bat, a .25 bat, and it's placed adjacent to the corner header on every single header course.
So why is that quarter bat, that seemingly tiny little piece, why is it so critical?
Because without it, you break the bond. If you just lay a header at the corner and then continue with your stretchers, when the next course comes up, the vertical joint between the first two units in that stretcher course, it will stack directly above the vertical joint below it.
Ah, so you lose your offset.
You lose the running bond offset for the stretchers. That little .25 bat kicks the header course back just enough, 2 inches, to make sure the vertical joints stay staggered like they're supposed to. It maintains the overlap.
And that's the geometric necessity. If an apprentice misses that quarter bat on an English corner, the visual consequence is immediate and, well, devastating.
The vertical joints just stack up, you lose the offset, and the wall just looks amateurish and weak. Now, in older, true multi-wythe walls, the ones where two sides are tied together structurally, the corner detail usually used what we call a queen closure.
And we should probably clarify that definition because it gets confused a lot. What exactly is a queen closure in this context?
A queen closure is a unit that's cut lengthwise along the vertical plane. So you end up with a unit that's 2 inches wide, but it still has its full length and full depth.
Okay, so on the face of the wall, it looks like a 2-inch vertical slice.
Exactly. And historically, these were full-depth units used specifically to complete the bond and tie the two withes together right at the corner. It helps establish that necessary staggering of the joints without messing with the wall thickness.
So the queen closure's strength is in its full depth, while the .25 bat's utility is its quarter length on the face.
That's a great way to put it. That clarifies the distinction perfectly.
But the most common technique used today, I'd say, for turning corners in both English and Flemish bond is probably the Dutch corner.
Oh, for sure. The Dutch corner relies on the 3/4 bat, a .75 bat, or a 6-inch long piece, to achieve that necessary reversal of the pattern.
Right.
And crucially, the .75 bat is placed on the corner of every course, not just the header course, like the .25 bat in the English corner.
This is where the geometry gets really fascinating. How does that placement alternate to get the pattern reversal?
Well, on the stretcher course, the 6-inch or .75 face of the bat is placed at the corner, and the rest of the course is just stretchers.
Okay.
Then when you lay the header course right above or below it, the short header face of that same .75 bat is placed at the corner, and the rest of the course is headers.
So that strategic alternation, it acts like a visual reset button right at the corner.
It does.
It takes the header course and makes it visually behave like a stretcher course as it turns the corner, and the other way around.
Yes, and this maintains the required offset and the bond visually, even when you're changing planes. It's a much easier detail to work with than a complex English corner because you're dealing with one standard cut, that 6-inch piece, that you just alternate course by course.
Which allows for faster, more predictable construction.
Which is why it became favored by masons.
Okay, let's move on to the Flemish bond. Now, if English bond is all about alternating courses, Flemish bond is about getting that classic checkerboard precision by alternating units within the same course.
Right. This is that sophisticated, highly visual pattern you often see on older Canadian bank buildings.
This is beautiful.
It is. The Flemish bond is distinct precisely because the alternating headers and stretchers happen in the same course. Every single course you lay will be a long face, then a short face, long face, short face, all the way across the wall.
This sounds simple, but the key to maintaining that Flemish visual pattern is, well, it's a geometric control that's arguably even tighter than the English bond.
Absolutely. The header unit in any given course has to be perfectly centered above the stretcher unit laid below it. That's what creates that beautiful, vertically aligned, crisp checkerboard look.
And I've seen so many apprentices run into trouble right here. If that centering is lost, if the header drifts even a couple of millimeters off center,
The whole pattern is ruined.
instantly, the vertical alignment of the headers across multiple courses starts to creep, and the wall just loses that professional look. That strict verticality is just, it's non-negotiable.
And historically, just like English bond, Flemish bond was used in those heavy, load-bearing 19th century structures. It was known for its strength in structurally tying the withes together, supporting the full building loads. It was especially good where you needed excellent lateral stability.
And once again, the corner detailing is critical. When you're establishing the proper bond pattern at the corner, right next to the first header, you need a specific shorter unit to kick the pattern back into sync.
Right. And if you're building a double withe wall, the preference is often that 2-inch queen closure we talked about, the unit cut lengthwise.
So it maintains the full structural depth.
It does, while giving you that necessary 2-inch reduction on the face to get the staggered corner joint.
But the Dutch corner is also an option here, right? Using that same 6-inch piece.
Correct. For the Flemish bond, the Dutch corner involves placing that single .75 bat, the 6-inch piece, on the corner of every single course. The alternation is a bit different here, though. You place the .75 bat's header face next to a stretcher, or you place the .75 face next to a header, depending on which side of the corner you're detailing.
It sounds incredibly technical, but I find that once you've laid one Flemish corner successfully, you start to just intuitively get why that shorter unit, the queen closure or the .75 bat, is absolutely necessary.
It's pure geometry. It forces the pattern to turn the corner and maintain its bond at the same time. And just to share a practical bonus application for Flemish bond, it's not always used for solid walls. It's frequently used in garden applications, specifically for building decorative screen walls or pierced panels.
Ah, the beautiful effect where the masonry looks woven, but it lets the air flow through.
Exactly. By intentionally leaving out the header in every course or certain courses, you create these carefully planned voids.
Right.
And this gives you a stunning, pleasant visual effect that allows for air circulation while still providing partial screening and structural rigidity. It's a very elegant use of a historical pattern in a non-traditional way.
Before we shift entirely into the ornamental patterns, let's just briefly wrap up the structural heavyweights by mentioning the American or common bond.
The American or common bond is probably the simplest of the structural bonds to execute because of its long repetition cycle. It's just a single header course followed by 5 or usually 6 courses of stretchers.
So that periodic header course was enough, historically, to join the double wide walls and provide that load-bearing capacity.
It was. It's a workhorse bond. It's less detailed than Flemish or English, but highly efficient for structure.
And for quarter detailing in the common bond.
We go back to the Dutch corner principle. To begin each header course and maintain the running bond alignment in the stretcher courses above and below, you use a 6-inch piece, a .75 bat at the corner.
And that just kicks the bond back into alignment for the next run of stretchers.
Exactly.
I should probably note, just for completeness, that there's a slightly more complex variation called American Flemish.
There is.
Which uses 5 or 6 courses of headers followed by a course of alternating headers and stretchers. But the standard American bond is that 5 or 6 to 1 ratio.
And this is a perfect point to transition. We've covered the structural bonds, which are defined by interlock and by depth. Now let's turn our attention entirely to alignment and artistry.
Right, and remember that mantra. 90% planning, 10% laying. This is where that ratio becomes, well, glaringly obvious.
It really is.
Because decorative patterns draw the eye. They magnify any mistake. I mean, if you think a slightly thick joint is fine in a basement wall, try laying a basket weave panel with inconsistent joints.
Oh, it'll jump right out at you. Accuracy is always critical, but here it's absolutely non-negotiable. If decorative work is slightly off-plumb, off-level, or if the unit alignment varies at all, that flaw is going to be the first thing you see.
The units have to be perfectly aligned, and a dead, consistent joint size has to be maintained throughout the pattern.
Otherwise, the whole visual effect just collapses. It looks sloppy.
Which means your tools of alignment are no longer just aids. They're your control system.
Absolutely.
Obviously, the level, the straight edge, and a tight mason's line.
Yeah.
But we should emphasize the specialty tools here. The bevel square, that adjustable arm that lets you set and check precise angles over and over again.
And the triangle square for checking your 90-degree and 45-degree cuts.
Yeah.
We just cannot overstate the importance of the dry lay imperative. This is step 2 in the ornamental process. It's right after you've measured the size of your panel, you've checked the surrounding walls for plumb, and you've built the running bond wall that frames the whole space.
So tell the listener, why do we absolutely forbid spreading a single trowel of mortar until the entire first course, or at least the pattern's repeat cycle, is laid out dry on a flat, horizontal surface?
Because that dry layout is your absolute proof of concept. It confirms that the pattern will fit geometrically within the space you've got. It lets you check for and strategically eliminate those dreaded small cuts. The piggies.
We use that term piggies for those awkward, tiny little cuts, maybe an inch or two long, that are nearly impossible to lay cleanly and just look awful when they're finished.
And the dry lay lets you see them and adjust your plan.
Crucially, it lets you make all your necessary cuts efficiently before you even start construction.
Right. You can line up 20 bricks and cut them all to the same angle in one shot, rather than stopping every 5 minutes on the wall to make a single cut while your mortar is setting up.
And one of the biggest initial planning notes that apprentices always miss is you have to account for the mortar joint along the perimeter. If you're framing a decorative panel in a wall opening, you have to remember to allow for that, say, 10-millimeter mortar joint, or whatever the specified width is, along the perimeter sides, top and bottom.
If you forget that 10 millimeters on either side, your entire panel is going to be 20 millimeters too wide.
And it won't fit.
That planning phase involves meticulous centering. The layout has to be centered both side to side and top to bottom. The goal is symmetry.
So any necessary perimeter cuts, those piggies you couldn't get rid of entirely, they have to be the same size on the left and right and the same on the top and bottom.
Exactly.
Can you give us a concrete, practical example of why centering matters and how you'd adjust if your initial dry lay shows a piggy?
Sure. Let's use a simple scenario. Say you dry laid your first pattern run, and it looks great, but you have a 2-inch cut, a piggy on the far right perimeter, and a full unit on the far left.
Okay, so it's unbalanced.
Right. That tells you your pattern is off-center by 1 inch to the left. So if you shift your entire center line 1 inch to the right, that 2-inch cut on the right will grow into an acceptable 3-inch bat. And the full unit on the left will now require an identical 3-inch bat. You've successfully balanced the cuts, and you've eliminated the ugly piggy.
That's a perfect example of solving problems on the ground before you're trying to solve them on the wall.
Yes.
And the herringbone pattern is probably the most obvious demonstration of why centering is so important.
It really is. To center a herringbone panel, first you mark the panel area clearly. Then you establish and mark your horizontal and vertical center lines. Then you use your triangle square to mark 2 precise 45-degree lines that intersect right at that center point.
And those 45-degree lines are your starting guides.
Exactly. You start laying your first unit along one 45-degree line and the second unit at a right angle to the first, and that forms your center chevron. By starting precisely at the horizontal and vertical center, you guarantee that the chevrons are balanced across the whole panel, which ensures the perimeter cuts on the left and right are symmetrical.
Okay, so let's talk about step 3 and 4. The actual laying and finishing, and how you maintain that geometric control.
Well, maintaining consistency is everything. Consistent joint thickness is vital, especially in patterns like stack bond, where the vertical joints are all aligned without any offset.
Right.
If your joint is 12 millimeters on course 1 and 10 millimeters on course 2, your pattern is already starting to creep.
And that's why we rely on specific tools for control. We use a story pole or a masonry lead with a mason's line, not just to maintain a level plane, but to maintain that identical coursing and joint thickness consistently.
The story pole ensures your head joints and bed joints are where they need to be, course after course after course.
And speaking of controlling creep, we need to talk about dimensional accuracy, especially for those highly alignment-dependent patterns like stack bond.
Oh, this is a big one. Bricks straight from the pallet can vary slightly, and that slight variation, it adds up fast.
How small are we talking?
For precision ornamental work, units have to be dimensionally accurate. We're talking within about 2 millimeters of one another in length and height.
That's a tight tolerance.
It is. If the units vary more than that, you have to pre-sort them. Laying a 198 millimeter unit next to a 200 millimeter unit means your vertical joint alignment is immediately thrown off. If you do that repeatedly over multiple courses, the whole pattern will start to creep out of square, and the result is just disastrous. Pre-sorting is essential to maintain that crisp, professional alignment.
Okay, so we've covered the structural heavyweights and the absolute imperative of that 90% planning phase. Now let's move into the purely ornamental bonds, the true artistry that relies almost entirely on that backing wall or subbase for its structural integrity.
And the herringbone bond is the gold standard for visual impact. It's arguably the most recognized ornamental pattern out there.
It features that unmistakable zigzag pattern, the chevrons or arrowheads, and the units are always placed on a precise 45-degree angle. It looks fantastic for feature panels, courtyards, paths.
And we classify 3 main variations based on the direction the chevrons are pointing. You have vertical herringbone, where the V's point up and down, horizontal herringbone, where they point left and right,
And diagonal.
and diagonal herringbone. And you can even find double versions where 2 units are placed side by side to form the pattern.
Let's just quickly reinforce the layout process for that. You've already found your 45-degree starting lines in the dry lay. The goal now is to maximize full units and minimize perimeter cuts.
Exactly. You laid the first unit along one of those 45-degree lines, and the second unit is laid at a right angle to the first, completing that first chevron. You keep using full units in the center field as much as you can, working your way out. Only once the center field is complete do you start to measure, cut, and fit all the perimeter infills.
And because that pattern involves so many units touching the perimeter at that 45-degree angle, it just requires an incredible amount of cutting and fitting.
It does. It requires patience, meticulous attention to the bevel square, and just accepting that it's going to take far longer than any other bond. This dedication to precision cutting and fitting is why herringbone has earned a certain reputation among masons.
Well, that brings us to our first rule of decorative masonry, which every apprentice learns pretty quickly.
I think I know where you're going with this.
Herringbone is a beautiful pattern, as long as you're being paid by the hour and not by the brick.
Yeah, that joke it's rooted in the practical reality of the labor cost. If you can lay 500 square feet of running bond in a day, you might lay 150 square feet of herringbone in the same amount of time.
The planning, the measuring, the constant cutting, it just fundamentally changes the pace of the job.
You have to account for that in your estimate and your schedule, or you're going to lose money and burn out.
All right, moving on to the basket weave bond. This is another highly decorative option that often gives the eye the impression of, like, a woven fabric or a complex checkerboard.
Basket weave is constructed by alternating sets of units that are laid in different orientations. You alternate sets of soldiers, so units laid vertically with stacked stretchers, which are units laid horizontally.
And these sets alternate, creating that woven square checkerboard effect.
Right, and to maintain this square geometry, all the units you use should ideally have identical dimensions.
So the key to the basket weave layout is really geometry and measurement that's focused purely on those square sets.
That's right. You have to first measure the precise dimensions of a single set, say 4 stretchers stacked 2 by 2, and that includes all the surrounding mortar joints.
Don't forget that critical 10mm joint allowance in every direction.
Never. That measurement ensures the single set forms a perfect square.
And then you take that perfect square dimension and you apply it to the whole panel area.
You mark and divide the entire panel area into equal squares based on that single set dimension. And before you go any further, you should set the 4 corner squares first to confirm that the pattern relationship works perfectly across the whole boundary.
You also have to remember to allow for that final mortar joint along the right-hand side of the panel during your initial layout marking.
Or you'll end up too tight.
Exactly.
Mm-hmm.
The challenge, even for a standard basket weave, is just maintaining those square geometries consistently.
And then, of course, you have the diagonal basket weave bond.
Which takes that square geometry and just turns it on its head.
Literally. It's often laid on a 45-degree angle similar to herringbone, which means you're back to making a ton of precise 45-degree cuts for any unit touching the perimeter of the panel. This is where your triangle square really earns its keep, making sure every cut is marked and executed correctly.
And because these patterns use such, evocative names, basket weave, herringbone, dogtooth, you get some funny misunderstandings from new apprentices.
Oh, the terminology can definitely lead to confusion if they aren't, visually grounded in the craft yet.
I remember once asking an apprentice to start a basket weave pattern, and 5 minutes later he came over and was sheepishly asking if he needed to soak the bricks to make them bendy enough.
Oh, that's a classic. That's when you know they're taking the name a little too literally.
Yeah.
That's a classic failure to understand that masonry is all about Geometry and angles, not flexibility. If you're struggling to make a pattern work, it's not the brick, it's the 90% planning you skipped.
The final major ornamental pattern is the stack bond. Visually, this one is the simplest and the cleanest.
It looks deceptively simple. It creates a perfect grid. All bricks are laid horizontally with all the head joints aligned vertically and all the bed joints aligned horizontally. There is zero offset.
And that lack of offset is the critical thing to remember. There's absolutely no overlap, which means there is no mechanical interlock whatsoever between the units.
And that lack of interlock translates directly into a very serious structural warning. Stack bond is inherently not a structural bond when you lay it without external reinforcement.
Right.
It has to be classified and treated as a non-structural ornamental bond. If it's used as an exterior or interior wall, it relies entirely on external mechanisms for its stability.
And the laying precision for stack bond has to be just absolute.
It demands dimensionally accurate units, like we discussed, and continuous use of the level. You have to plumb those vertical joints continuously, course by course, because there is no mechanical overlap to visually or structurally guide the next unit into position.
If you rush, those vertical lines will wander instantly.
Immediately.
And let's bring the code context in here, because this is where the apprentice has to become the knowledgeable artisan.
Right. If you're laying stack bond in a wall in Canada, you're operating under very specific code requirements, like CSA 37114 8.1.3. And this standard dictates that stack bond must use wire joint reinforcement and proper anchoring to a backup wall. Typically, this means 2 wires of 9-gauge steel or equivalent, placed every second course and mechanically anchored.
And without that prescribed reinforcement, that wall has minimal structural integrity.
And it may be legally non-compliant.
Which, naturally, leads to the structural joke about the stack bond.
Yes.
Stack bond. Because why have structural integrity when you can have a wall that looks like a giant grid of good luck?
It's funny because it's true. It's a high-risk bond, both visually and structurally, if you don't follow the reinforcement rules perfectly. The beauty of the grid depends on perfect alignment. The stability of the wall depends entirely on the hidden steel.
Okay, now let's push beyond the flat two-dimensional patterns and talk about surface modeling, where the masonry units themselves start to sculpt the wall face, adding texture and shadow.
Surface modeling is basically any masonry work that gives a three-dimensional quality to a wall by strategically using projecting or recessed units. This is how you introduce dynamic texture and shadow play into a facade, giving it depth and character.
Before we get into specific patterns, a critical material warning for our listeners.
Yeah.
When you start projecting units outward, you introduce specific vulnerabilities to the elements.
Especially the freeze-thaw cycles we get here in Canada.
Exactly.
You have to use frost-resistant solid bricks. That means units without cores or indentations deeper than 10 millimeters. A projecting header with an exposed core will collect water, freeze, and spall, and it will just destroy the look and the durability of the wall.
You should also be prepared to use two-face stretchers where you need them for clean visual returns.
Right.
Dogtooth coursing is a classic example of this surface modeling technique.
Yeah, this bond creates a continuous horizontal band of units that are laid on a 45-degree angle so that one corner projects out sharply, like a tooth. It's often used as an accent or a water break.
And it can be laid in 2 ways. Projecting, so the corner sticks out from the main wall face.
Or recessed?
Right, or recessed, where the entire unit is pushed back, so that the projecting corner is actually flush with the main wall face, which creates this strong line of shadow right above it.
Dogtooth coursing is a great test of pre-cutting skills. You need a solid, clean 45-degree angle cut on the back of the unit to make sure it sits flush against the bed course below it without leaving a visible gap behind the projecting point.
So as the craftsman, how do you manage that repeated 45-degree cut efficiently?
You set one unit dry on the wall at the required 45-degree angle using your triangle or your bevel square. That first unit then becomes your template. Then you use that template to mark the backs of all the remaining units you need for the core so you can batch cut them on your saw, ensuring consistency and speed. If you try to cut them one by one on the wall, you're going to lose time and accuracy.
Another common ornamental detail, often found toward the top of a wall, under cornices or around archways, is dentil coursing.
Dentil coursing consists of projecting headers that alternate with flush headers or flush stretchers. Visually, it looks like a repeating set of small, square teeth running along the facade.
And this detail has some pretty strict geometric rules.
It does. The projecting units shouldn't project more than 1/3 of the unit's width. If they project further, they become unstable and vulnerable.
Right.
Also, the core of the unit must never be exposed. And, geometrically critical, the projecting headers have to be centered above the stretcher below it, which ensures that vertical joint is staggered and the bond remains strong.
And the laying technique for dental coursing is actually reversed from standard practice, isn't it?
It is. If you started with the projecting units, they'd just obstruct your mason's line, forcing you to constantly move it. So you should lay the flush units of the dental course first, using your line to guide their top erise.
And once those flush units are in place and perfectly centered over the units below.
Then you lay the projecting headers.
And when you're laying those units, especially the projecting ones, you have to be meticulous about full mortar coverage.
You have to butter both the projecting and the flush units thoroughly to ensure a full vertical joint. You also need to use a small level frequently to check that those projecting faces stay perfectly plumb and don't tilt up or down, ruining that clean visual line.
Okay, finally, let's discuss soldier coursing. Units laid vertically in the soldier position.
Soldier coursing is incredibly popular as a strong, decorative band used at the top of doors, windows, and walls. It can be laid flush with the wall face, or, more commonly, it's projected, maybe about 10 millimeters beyond the main wall face to create a subtle but distinct shadow line.
The complexity here isn't the straight run, it's the corner returns, when that vertical course has to turn 90 degrees.
Right. The simplest and most professional method is to specify and order special corner units. Solid units without cores that are known as standard specials.
They're purpose-built for that.
They are. They eliminate cutting and maintain durability, but they aren't always available on short notice, or sometimes the budget just doesn't allow for them.
So we have to resort to fabrication on-site.
And the primary alternative is using mitered units. You cut 2 units in half lengthwise on a precise 45-degree angle, making sure the stretcher faces remain intact.
Good.
These 2 mitered units are then pinned and heavily mortared together, sometimes using epoxy or mechanical fasteners for extra integrity, to form a perfect, clean, vertical corner. This requires perfect, clean saw cuts.
Are there faster, less detailed methods?
Yes, although they are less visually appealing. Some masons will just use stack-bonded stretchers at the corners, or allow the corner of the soldier course to follow the coursing of the units right below it, but that usually breaks the uniformity of the stretch band.
So the mitered unit, or the standard special, is the true professional approach.
It is.
And regardless of the method you choose, once the returns are set, the laying process requires extreme care.
It does. Once your corner returns are in place, you attach a line to guide the top eris of the soldiers. If the course is projecting, a second line, or just near constant use of the level, is necessary to check for plumb. And you have to butter those units thoroughly to ensure full vertical joints.
Right.
Soldiers are inherently more unstable than stretchers, so full mortar coverage is paramount for long-term stability.
Okay, one final, highly specialized area of ornamental work, a true combination of artistry and masonry, is sculpted clay masonry.
Yeah.
When you see those intricate architectural details, maybe faces of people, nature scenes, or historical dates on older Canadian buildings, this is often what you're looking at.
This is a specialized, time-intensive form of masonry that demands genuine artistic talent. The materials used are typically solid units, and they're usually sculpted before they're fired, when they're still what we call green or unfired.
So they're soft and easy to mold in texture then.
Exactly. The process is fascinating. It's basically building a clay sculpture, taking it apart, baking it, and then putting it back together on a wall.
That's a great way to put it.
The units are placed together on a table, sculpted as a panel, meticulously labeled according to their position, top left, center right. Then they're taken apart, fired in the kiln at high temperatures, and then finally installed on site by a skilled mason who follows the exact map of the original sculpting.
And there are 2 main methods used for the sculpting itself. The first is intaglio.
Intaglio comes from the Italian verb to cut in. This involves carving the desired image into the face of the unit, which means the finished image is recessed and rests below the surface of the panel face. When the light hits it, the carved-out area is defined by shadow.
And the second method is relief.
Relief is the opposite. It's created by carefully cutting away the background clay that surrounds the desired image. This results in the finished image being raised above the surface of the panel face, making it stand out prominently in the light.
And sculpting fired brick.
It's possible, but it's extremely labor-intensive, similar to hard stone carving. It requires specialized diamond saws and chisels, and it's usually only done for repairs or very minor changes.
Okay, let's take a moment to kind of synthesize what we've covered and connect the past, present, and future of Masonry for our listeners. We started with the historical structural bonds, Flemish, English, and common.
Which were all defined by the power of that full-depth header unit to tie two withes together.
Right. And then we explored how those same bonds are now largely decorative, using snap headers and relying on modern engineered ties.
And then we shifted fully into the purely ornamental patterns, herringbone, basket weave, and the challenging stack bond, where the beauty is purely in the alignment and the structure relies on what's behind the pattern.
But the central thematic shift, the biggest takeaway we want the listeners to carry forward, it still remains the dry layout process.
The 90% planning phase.
That's the thing that separates the apprentice who just lays brick from the master craftsman who builds lasting quality.
You have to check for centering, you have to manage your joint consistency, and you have to pre-cut your materials to minimize job site errors. If your planning is thorough, the execution becomes manageable even for the most complex patterns.
And remember the jokes. Don't confuse geometry with flexibility in basket weave. Plan ahead for the long hours of herringbone, and never, ever forget the steel reinforcement for stack bond.
Your craft is judged not just by the beauty of the final mortar joints, but by all that preparatory work.
Now, as you move forward in your journey, look at every ornamental bond you see on a job site with new eyes. You know the visual pattern now, but start thinking about the structure.
When you look at an old building with a solid wall Flemish or English bond, you are seeing history held together by sheer brick interlock, by full headers spanning the entire wall.
But when you build a modern ornamental panel, whether it's stack bond or herringbone or a veneer of English bond,
the load-bearing duty shifts entirely to engineered ties, the backup structure, and code-required reinforcement. As you encounter these jobs, the true measure of your knowledge will be to consider not just the pattern's visual beauty, but where the true structural burden lies in every single wall you touch. How does the choice of bond, or the lack of mechanical interlock in that pattern, directly dictate the minimum necessary reinforcement required by Canadian code? That is the mark of a truly knowledgeable professional craftsman.